Hey everybody. I got a request for an example for one of the homework problems. The request is for two. They're pretty similar, so I'm going to do just one of them, which I think is the harder of the two, and see if that helps. I'll come back and answer more if there's still questions, but I'm hoping this one response will be enough. So this comes from section for us. It's one of the problems in 11.2, and it asks, let's see, the question looks like this. It wants us to find out if this series maybe they give a couple more terms. Let me see. They give one more, so I'll do the same. They want to know if this series converges or diverges, and then if it converges, what it converges to, right? So we want to see if this is something recognizable to us. And we haven't seen that many series, especially at this point. And so there's only a few options we have. So one thing we might consider is thinking about how we get from one term to the next, right? Maybe we add the same thing over and over. Maybe we multiply by the same thing over and over again. So for instance, if I try thinking about what the difference between these terms are, it won't take you long to see that the differences change each time. There's not the same difference between each of them. So I might try something like noticing the ratio between them, right? To get from 8/3 to 16/9, I'm multiplying by 2/3. And to get from 16/9 to 32/27, I'm multiplying by 2/3. And to get from 32/27 to 64/81, I'm multiplying by 2/3. Right? So this gives me a hint that this is our geometric series, right? And so the geometric series, one of the ways that we can write it is this first term times the common ratio to the n-1 power, right? And you can check this, right? So I'll let you go through it, but put in n equals 1, you get 8/3. Put in n equals 2, you get this one. N equals 3, you get this one, and so on and so on. Well, if you remember, our geometric series has a known sum whenever the absolute value of the ratio is less than 1. So in this case, our ratio is 2/3, which is less than 1 in absolute value. And so that means the sum of this series is A, the constant in front, over 1 minus this ratio, right? So we end up with 8/3 over 1/3, or 8. Okay. So the other video request was, I'll give this hint, was also a geometric series, and the key is figuring out how to write it in this format, right? This is the rule as given in your book, and I developed it in one of the lectures as well. So if you can figure out what's playing the role of A and what's playing the role of R, then it's simple enough to understand, plug in what you need to plug in and get this computation. Okay, that is it for this one.